Good evening, everyone, and welcome to another episode of Starstream by Focus Astronomy. And tonight we're going to be doing something a little bit different that we've never really done before, and that, of course, is observing the moon and Venus. And we've got two telescopes running right now. There we have our standard 6-inch refractor. Our Skywatcher Esprit 150 triplet is outside. And that's got our main imaging camera on that tonight, which is a Starlight Express 694 monochrome camera. And then, of course, on top is our latest edition, which is another Skywatcher 100 millimeter ED doublet. It's an EvoStar ED doublet refractor, and we have a TeleVue 2.5x PowerMate on there with a point gray camera, a monochrome black and white camera. So with all of that said, we're just going to jump into it this evening because we've got a lot to cover, especially because we're going to be on the moon for a good portion of the night. So let me pull up our imaging setup here, and we will get on our way to view some pretty cool stuff tonight. So scoot this over here, and if you have any questions, you can obviously ask that over in the live chat. I can always get over to a target for you, but feel free to ask questions. We're going to be perusing a lot of lunar objects tonight, some of our solar system, and then wrap it up with some deep sky stuff. But tonight's really showing us ultimately what you can do from a light polluted location with a bright moon, and we are gonna get over to that. All right, now what we have up now is Venus. If you step outside right now and look out to the west, you'd see a very bright object. Looks like a bright star, but in fact that is the planet Venus. And that's where are we tonight? Planet Venus, 39 million miles away from us tonight. What mount are we using tonight? We're using our Paramount MX. Software Bisque Paramount MX is the mount we're using tonight. That's kind of our go-to mount. So if you're just joining us, the telescopes that we're using tonight, our Deep Sky telescope is a Skywatcher Esprit 150 triplet, so it's a 6-inch refractor. It has a Star Arizona Apex reducer, so we're running the telescope at f4.5, and then we have a Starlight Express 694 monochrome camera with a 7-position filter wheel with all the bells and whistles, luminance, red, green, blue, hydrogen alpha, O3, and S2 filters available. And then piggybacked on that is our Skywatcher EvoStar 100 ED. Has a 2.5x PowerMate from TeleVue in there, so we're running about 2200 millimeter focal length, and that is a point gray monochrome CMOS camera. That's for the moon and the planets. And that's actually what we have up right now, is the planet Venus. And this is running through the 4-inch refractor that's piggybacked on the 6-inch telescope right now. And we're looking at Venus. Venus right now is 39 million miles away from us. And it has a diameter of about 3,760 miles in diameter. So it's a little smaller than Earth. Now, Venus is kind of cool because it's actually the hottest planet in the solar system with a surface temperature of about 864 degrees Fahrenheit. Perfect for roasting marshmallows. That's actually hot enough to melt lead. And this is actually the brightest object in the nighttime sky right now, other than the moon. And you can step outside right now look to the west and you'll see it. Nice, bright, kind of a creamy color star, which is not a star at all. It's the planet Venus. And Venus is really interesting because it sits within the orbit of Earth. So we're looking, obviously it goes Earth, Venus, Mercury, and then the Sun. So Mercury and Venus are within Earth's orbit. So we have the ability to look from behind the planet. And because of that, we're able to see phases just like the moon. And what we're seeing right here is Venus, because we're looking from behind the planet and it's being illuminated by the sun. Now there's a lot of heat right now because Venus is getting rather low, and we're looking over some other houses and buildings. And here in Arizona, it's been a little toasty the last couple days, so there's a fair amount of heat that's coming off the ground and affecting it. But this is the planet Venus. And Venus is pretty cool. It's the hottest planet in the solar system, 864 degrees Fahrenheit on the surface. And my favorite thing about Venus is its day is actually longer than its year. The orbital period for, or the day on Venus is about 116 days and 18 hours for Earth. Which is crazy. So it's really kind of a bizarre place. It doesn't spin very fast, and it also spins backwards. So if we were on Venus, the sun would theoretically rise in the west and set in the east. So Venus is a very oddball planet, and it's always something that you can go out and check out without a telescope. But a small telescope can be really cool to unveil the phases of Venus, and you don't need a very big telescope to do it. I've done it with like a 70 millimeter refractor, and it doesn't take much, some high magnification, but if you're using like a moon filter or a polarizing filter, you can get the glare out of the way and you can start to see the phases, and that's kind of a fun thing to check out if you can. So this is the planet Venus. This is visible right now in the western sky. You can easily be seen. And we do have a red filter in the light path here. It cuts out some of the glare and gets rid of some of the other wavelengths of light that might be affecting the quality of the image because of the heat. So if you use an infrared pass filter, something that cuts out the all the colors except infrared, way over in the red part of the spectrum, or red, you can kind of get rid of some of the boiling effects of the seeing conditions and kind of get a sharper image. And that's why we're using a red filter. Now, because the camera is black and white, you'll never really notice that. But let's see if we can switch the camera up here real quick and reposition it. There we go. So this is the planet right here, and then you see the curve in there because planets are round, they're not flat. So we have a beautiful little crescent right here, and as it makes its way around, it'll get thinner and thinner and thinner, just like the moon does. So this is the planet Venus, 39 million miles away roughly tonight, and hottest planet in the solar system. So with that being said, this is the only planet we have up right now. All the other planets are up in the very, very late evening or the morning sky. That's where you have Jupiter and Saturn and Mars. All the naked eye planets are up in the early morning, and hopefully as we move into summer and fall, we'll be able to get some of those on these live streams. But for now, we've got Venus, and having the phases is kind of cool. So if we're all done looking at Venus, and we can always come back if you guys want to see it, but the big thing for tonight, of course, is the moon. And we've got a lot of stuff to check out on the moon tonight. So I'm going to flip our software here, and we're going to have the telescope slew over to the moon. And if there's anything you want to see that I haven't gotten to, please let me know, and I'll do what I can to get over to that for you. So the mount slewing over to the moon right now. We just left the planet Venus. And if you want to go back to Venus, we certainly can. But right now we're going to head over to the moon and spend some time on the moon. We've got a lot of craters we want to check out and all kinds of stuff on the moon. We could do a whole thing on the moon. if we wanted to. Maybe one night we'll do that. Maybe get some of our friends on the chat here that are good with the moon, because that would be kind of cool. So let's see if we can get the moon pulled up here. Let's see. All right, now we're making our way over to the moon. And the moon it's making its way towards full right now. We're past first quarter, and the full moon for May is not too far away. Full moon for May is actually May 7th, and it's not that far away, and this will be the flower moon. Let's see, here we go. So there is a lot of heat out there right now, so the image is a little soft tonight because it's been rather hot outside. Let's move it. Here we go. And let's adjust our exposure here. Whoop. All right, so we are on the moon, and like I said, we're not quite full. This is a just past first quarter moon, and right now, let's get some position over here. There we go. Now it's pretty hot tonight, so things are not as sharp as they could be at the moment, but so let's see. All right, so starting with these dark regions that we're working with right now, these are called mare, or seas, and there are several of them. So if you ever go out in the nighttime sky, or I'm sorry, if you ever go outside and you want to actually check out the moon, it's something that you can actually see all these dark regions, and it's pretty cool to see because there's so much on the moon that you can explore, and it's a very dynamic object with so much going on. And so we're going to start out with these darker regions first and get kind of an idea of where we're at on the moon. So the first one right here is, so first off, the mare are all these dark regions, and mare is actually the Latin word for seas. So these are things that you can see with your naked eye. And let's see, where are we right here? So right here, starting with this one, and I have a little box here that we can actually pop up here. Oop. This will be our little pointer box, and let me there we go. Right there, this is actually the first one we're looking at. This is the Sea of Crises. Sea of Crises is actually about 345 miles across, and it's rather big, and all these dark regions are going to be that way. And what's cool about these are low-lying areas that are rather young in compared to all the white regions out here. And with that, this can tell us some of the different ages of the portions of the moon. So mare have been filled in long ago by lava flows and all kinds of other things, so they're lower lying regions, and we know they're not as old as some of the other regions is because they're not littered with craters, and that's how we can kind of tell the age. The highly peppered areas with craters, those are older regions, where the mare are younger. They have not been subjected to as many impacts as others have. So this is all something that is rather new and has been filled in. I'm going to see if I can run out real quick and try to get this a little bit more focused, because it should be a little bit better than this, and we'll get a nice sharp image. So bear with me just a second, and I'm going to go out and focus this, because the second telescope doesn't have the fancy automated focusers that the main telescope does. So bear with me just a second, and I will be right back. All right, much better. We'll get a motor focuser on this next time. So now we're all focused. A lot sharper image now for the moon. It'll be a lot easier to point out some of the details here rather than looking at a big blurry image. So we're talking about this guy right here, and this is the, like I said, the Sea of Crises, 345 miles across, edge to edge. And like I said, these are lower lying regions. All these dark regions, they're called mare, which is the Latin word for seas. So, and we have a couple of them in here. We're going to kind of go over them throughout the evening. So, but this particular one is the Sea of Crises, right there on the edge of the moon. And there's a couple craters inside of there. We'll see what we can pull out here really quick. So this little guy right here, and most of these are going to seem small, but they are far from it. This particular crater right here in the Sea of Crises is actually known as Picard. And this particular crater is about 22 kilometers in diameter. And that's rather small for some of these craters. We'll get to some bigger ones. So this actually works out to probably about 13 and a half miles in diameter. Right here is what we're looking at. So, you know, we've got pretty good resolution for a small telescope. And this is all something you can check out at home. So like I said, this is the crater Picard. Let me get my little box here. And square this up real quick. There we go. Right there, right in the middle of that box. That is the crater Picard. And like I said, that's about 13 and a half miles in diameter, which actually sits inside the Sea of Crises, which we are right here. Now, as we make our way over, we'll head down to another sea. Let me get our controls here for the telescope. And drop this over. Slow down our slewing before we fly off the face of the moon. Oop, other way. And the moon's a really cool object. I actually don't give the moon enough credit personally. I really need to spend more time on it because it really is a particularly cool thing to view, and most of us kind of just shrug it off because, you know, we want to look at those faint little objects. So we've actually moved downward on the moon towards the southern pole. The camera's actually kind of flipped right now, and this particular we're in a new particular region right here, another mare location. And this is the Sea of Fertility, which is right. Let me move my box real quick and grow it so we know what we're talking about. This is the Sea of Fertility right here. And the Sea of Fertility is about much bigger than the Sea of Crises. When we were talking 345 miles in diameter for the Sea of Crises, this is 542 miles in diameter for this particular sea, and it's really kind of neat to see all what's in there. And there's some pretty neat craters that sit inside of here, like this one right here. Down here you can actually see the ray trails of that impact that just flew in and smashed into the moon right there, sending all this debris out. And this is called Messier A. And then, of course, it has its little partner right next to it, just in front of it. And this is, so you have Messier, which is this guy right here. Let's see if we can zoom in real quick and get a better centered view. There we go. So we're talking about these two craters right here. The rear one right here is, or let's do the front one. The front one is Messier, and then we have Messier A back here in the center. So it's kind of cool. You can see all the ray trails coming off of that crater system down there. And that is Messier, and this sits in the Sea of Fertility, which is this particular crater system. Not crater, I'm sorry, mare. Mare and craters are different. Craters are from impact, like meteors and meteorites, where mare are actually low-lying regions that have been filled up with material over the history of the moon. And these are actually a lot younger than the highland areas. And we know that because you can see the highlands are bombarded with all different craters, where the mare are not as old because they haven't been impacted as much. So that's how we can tell older material versus younger material. And this is the Sea of Fertility and some of its craters there. Now, a little further down from this sea, we have a very large crater, and I'm going to mosey the telescope down there real quick. There we go. So right here in the middle, there's another very large crater. And this is just below the Sea of Fertility, right on the outer edges. And this particular crater is Langrenus is the name of this crater. And this is a very large crater. And we're talking about 82 miles in diameter. So you could fit a good city inside of this crater. And it's also 1.7 miles deep in its deepest area. So it's deeper than the Grand Canyon. So it's quite a crater there. Now, this was named after Michel Laurent von Lagrange, who was the first person to actually draw a lunar map while naming features on the moon in 1645. So he actually named the crater after himself. So that is the crater right there, and that is the crater Lagrange, and can easily be seen in a telescope. Or Lagranus, I'm sorry, that's the name of the crater. 82 miles in diameter and 1.7 miles deep, and my box is right over that. So let me reposition our box here so we can actually, talk about what we're talking about. Right there in the middle, that is the crater that we're talking about, as the crater Lagranus, just off the Sea of Fertility, which is right down in this position, this gray area. 82 miles across, 1.7 miles deep. So it's quite an interesting crater system, and you can see all the rays of material from that large meteorite that came down and smacked into the moon and made that crater. And that's where all these craters come from, is just meteorite impacts. So it's constantly being bombarded because there's no atmosphere, there's no geology, active geology going on, or erosion happening on the moon. So a lot of this is constantly just there. It doesn't fade like things would here on Earth. So that's kind of why we have all this stuff still up there on the moon, and allows us to enjoy all of this constantly. So shifting gears, we can cruise around the moon here and bring ourselves upward. We'll center this guy right in the middle. And this is our next target right here. And let me bring up our square once again. And that way everyone can see where we're actually talking about. Right there in the middle. This is usually the one that we all know about, because this particular mare or sea right here in the middle is the Sea of Tranquility, and is most famous for Apollo 11 and its landing site. And let's see if we can find where exactly Apollo 11 landed in this particular region. Try to pull up a map here on the side, and we'll try to figure out where exactly those are. But this is the Sea of Tranquility, like I said, made famous by Apollo 11, which actually landed right about in here, it looks like. Is that right? Yeah. So right in this region, right about in here somewhere, is where Apollo 11 actually landed several years ago at this point. Sea of Tranquility is 544 miles in diameter, and obviously made famous by Apollo 11. So this right here is the Sea of Tranquility. It's got several craters inside of there as well. And once again, this is the Apollo 11 landing area at this point. So we're looking right here, about straight across in this region, right in here is about where Apollo 11 actually landed. So kind of cool. This is also stuff that you can see with your naked eye, but a small little telescope, you can do this too. So go out there, give it a shot, see what you can definitely find out there. Scooting over a little bit more, we have another sea just above it, as we head north on the moon. And let's get our controls here and head back up the moon. And right there in the center now, right in the center of our little box, this is the Sea of Serenity, another one of those low-lying regions or mare on the moon. And the Sea of Serenity is a little bit smaller, about 419 miles in diameter, and it's got its own set of pretty neat things right there on the limb of that. So the first one, of course, is this crater, and a lot of these are Latin names, so of course we all are going to butcher them. But this is Menelaus, and I probably butchered that, but that's okay. Another little crater on the rim of the Sea of Serenity. And this particular crater, it's not huge either. This one is only 16, almost 17 miles in diameter, but it's right there on the crater edge. And all these can be seen in a relatively small telescope. It doesn't take a lot of effort to view a lot of these craters, so it's something fun that you can go out with the family and look at the moon. You don't have to drive anywhere exotic to see it. You can do it in the worst light polluted locations on Earth. The moon is always there to share. So, pop out some binoculars or just go stare at it for a little bit. It's kind of cool. So we did some of the big seas. We did the Sea of Fertility, Sea of Crises, Sea of Tranquility, which is right here, Sea of Serenity. And then just above that, as we continue onward up towards the northern portion of the moon, we come up here to one of the largest mare on the moon in this particular hemisphere. And this right here is the Sea of Showers. And it's actually just starting to get sunlit. So it's sunrise right over in here. And this whole ring right here is the Sea of Showers. And 419 miles in diameter. I'm sorry, 712 miles in diameter for this one. Now, what most of us see right now is if you go outside, you'll see the shadow crossing the face of the moon. And that is actually known as the Terminator. That is the real terminology. I'm going to turn off my little square here. But the shadow, as it crosses the moon, its technical terminology is called the Terminator. So something kind of fun. And that's this region right here. And this will actually continue to light up as we make our way towards May 7th, which is the full moon for the month of May. It's the flower moon. And so this is where we're at right now. And there's a variety of craters that are actually inside of the Sea of Showers. And we're going to talk about those right now while we're on this particular spot. So the first of these craters, which you can actually see, is Archimedes, which is right here. Let me turn on my little square once again so we can kind of position what we're looking at rather than me using my pointer. So right in the center here is Archimedes, and that's what we're looking at right now. And Archimedes is another crater. It's 50 miles in diameter, 1.3 miles in depth, and this is located inside the Sea of Showers, and it's currently sunrise there, so that's why it's still shrouded, but we can bring up the camera exposure a bit and bring out some of that really awesome detail, and it really starts to come out. And this is Archimedes right here in the center. Now, if you're just joining us, this is a 4-inch refractor. It's a 4-inch telescope. There's not a big telescope in it. You can really do a lot of cool stuff with such a small optic and a real basic little camera if you want, but even an eyepiece would be great on this. So you can do a lot of cool stuff with it. So we're in the Sea of Showers, 712 miles in diameter, and then we're looking at one of its craters inside, and this is Archimedes. Now Archimedes has a couple other little friends nearby. This one right here, let me scoot this up real quick, right here in the center of the box. This is Autolocus, another crater in this particular sea, and this is only 24 miles in diameter, so it's about half the size of Archimedes, but it's 2.1 miles deep, so it's almost twice as deep. So whatever hit it had some real penetration into the surface there. So really interesting craters and all the details in there. And then the next one right next to it, which is kind of the medium size of the 3 craters in this particular region, which is now right here. This is Aristillus, 34 miles in diameter and 2.2 miles deep. And you actually, whatever hit it with enough force to actually give us a centralized peak, which you can see on some of these other ones, like this one here and the one over here on the side, which is another crater, and that is Eratosthenes. And again, I'm butchering some of these names. But these are all craters that you can check out. Now, along with all of this, you'll notice the ridgeline that's actually up here. And you can easily see this right in here. So this is actually Montes Apenius, which is a mountain range. And it's actually named after the Apennine Mountains in Italy. And this particular region up on the moon there is about 370 miles long, and about 3 miles in height on some of the highest regions there. So this is a full-fledged mountain range up on the moon. Very, very cool. It's right on the limb of that sea of showers, right there on the heading towards the northern portion of the moon. These particular mountains right here, like I said, these are almost 3 miles high in certain regions. So this is an actual mountain range. These are no hills right here. It's a serious hiking endeavor at that point. So pretty neat details right there with those. Now, not too far from where we're at the moment, kind of hidden in the shadows, is my favorite crater on the moon, and one of the most well visible ones when the moon is actually lit completely. Let's kind of cruise down here real quick and get a good view of it, because it's just starting to come out of the shadow. Tomorrow it will be more illuminated, so if you've got a telescope you can step out and see it. This particular crater that we're looking at right here is the famous crater Copernicus, and obviously this was named after Copernicus, Nicholas Copernicus. This crater is 58 miles in diameter and 2.3 miles deep. And you can see it's just starting to light up some of the outer area right there. So the outer limb of the crater. And this was quite a hit when this finally took a major impact on this one. And this is just outside the sea of showers, which we were just on. But this will be right on the shadow line and will be really well detailed probably tomorrow night as well. You'll get some of that deeper shadow inside that crater tomorrow night, which you can actually see in very, very small telescopes. So this is the crater Copernicus, 58 miles in diameter, 2.3 miles deep. Very, very cool crater to check out. Now the next one we're gonna go check out is, let's see, there's all kinds of stuff that we can do on the moon, and we can just cruise around, especially with the telescopes. It's really kind of fascinating to see all the different things hidden in there. And one that's really quite popular, we're about a night or two past optimum viewing for this particular one. Let's see if we can find it. There it is. Let me center this up real quick, because you can just start to see it come through. It would have been better probably last night. Right around first quarter is when you want to see this. But let me see if I can get we're going to try to zoom in on this too. Let's adjust the camera and see if we can get better centered on our particular object of interest. There we go. Right in the center here. You get my little box. Boop. There we go. This is a really, really funny, not even funny, this is a really cool area that you can see. This is called the Straight Wall. Is this right here. And the Straight Wall is 68 miles long and about 650 feet high. And it's actually a what used to be, I guess, a fault line. There's no geology on the moon at the moment, but this is a leftover fault on the moon, and that again is called the Straight Wall. Very fun thing to look at when you're right around the first quarter moon, where it's about half lit, and then it's got its little crater companion right next to it, known as BIRT. Is actually the BIRT. That is the name of the crater BIRT, and it's 3.7 miles wide. So you can kind of see the resolution that we're getting is up to probably about a mile in resolution with just a basic telescope. So the little guy right next to it, which is a companion of this crater, BIRT, is also there. And I don't have the documentation for that one this evening. Let's see if we can find it real quick on our handy. That is BIRT A. So we have BERT and BERT A. So, and then of course the straight wall right next to it. So we're on the moon, obviously, the big golf ball in the sky. There's thousands of craters on the moon. We could do an entire evening just dancing around the moon. And let's go back up to full frame on the camera here and get all of it. There we go. And we can kind of just step down to the southern pole real quick, and you can see there's so many craters down in this region. This is the southern pole of the moon, and just amazing details. Like I said, that big golf ball floating up in the sky there, and you can spend, I have friends who this is all they love doing this, and they're all about the moon. And the moon's really cool because it doesn't matter where you are in the world or what city you live in. It doesn't matter if there's light pollution or anything like that. You can get a really nice beautiful view of it, and it's always there. So to wrap up the moon real quick, unless there's something you guys want to take a look at here, is this crater. This is Clavis. And Clavis is another very, very large crater. This is 143 miles in diameter, so you could fit most major cities within this. And then it's got a bunch of craters inside it. So this is an older crater, very large crater, and it is 2.1 miles deep. And then it has a collection of smaller craters, obviously, inside of it. So that is the crater known as Clavis. So something cool to check out. And like I said, there are thousands of other craters that you could just pop out a little telescope and check all that out. And we'll slew around here real quick just to give you guys a little view of what's up right now. And this is only a 4-inch refractor. A little overexposed. There we go. This is just a 4-inch refractor, nothing super fancy. You don't need anything, super high end to enjoy the moon. And this is out right now, so even when this is over, you have about half the night to go out and check out the moon. So give it a chance. Go check it out afterwards and see what you can do and explore for yourself. So this is the moon. And that's pretty much going to wrap up the moon part of our broadcast, because now we're going to have to switch over to the cameras on the larger telescope, the 6-inch refractor, and get on to the deep sky part of this broadcast. So let me go ahead and turn this section off. Thanks for that, camera. And we're going to go ahead and go full screen on our main controls. And let's flip some of this stuff off. We're going to get our main camera hooked up and ready to go. And hopefully we have no bugs. Always a joy when you're working with so many different systems to make this going. Let's see, Roy, does one side get more meteor strikes than another? That's actually a good question. The moon should probably get equal strikes across it. It's just kind of a luck of the draw depending on where things land, but for the most part you should be just perfectly fine getting even amount of impacts around there. So let me double check that everything is on. Yes, so our camera's on, filter wheel is on, and the focuser is on. So we're going to flip off the moon here. Our moon telescope is now off, and we are ready to start the deep sky part of the evening. And we're going to start going off the deep end here with a lot of different objects as we slew around the sky. So we're on our first target right now. Alex, what scope are you using for the moon? For the moon, we're using a Skywatcher EvoStar 100 ED refractor. It's a 4-inch refractor. It has a TeleVue 2.5x power mate, so similar to a Barlow. So the telescope is natively an f9, and with that power mate, we boost up the magnification capabilities on the telescope, and we take that to f22.5, so 2250 millimeter focal length at that point. All right, so we're on our first target, and we're going to get all the filters flipped over. We're going to get our cameras, and let's see how things are going tonight. Let's get this going. I have to double check, make sure everything's good to go. Last night we were a little cloudy here, so I wasn't able to get everything completely dialed in. So we'll do our best tonight to make sure everything looks good. So we're taking our first exposures here now of our first target. I just want to make sure if we're in focus or not. It's been a little bit. Yep, we are out of focus. So we're going to stop this real quick. I'll show you how we focus the telescope real quick. Now, this is an automated system. When we're not doing imaging setups like what we're doing right now, this system is actually designed to run automated by itself all night. So what we do is we actually program the telescope and the whole setup and actually get it to where we can actually basically let it run by itself autonomously throughout the night. So I can go to bed and it does the rest. So that's pretty common. So what we're doing here right now is we're getting focused. So out on the telescope, we actually have a motor on the system, and that motor actually will focus the telescope. It can read temperature and make sure everything's looking okay. So we had to just make a minor adjustment and we're all set. Let's get back to our cameras here real quick and get on target. Go back to take photo, live stack. All right, so we're doing 15-second exposures right now, and we're using our green filter, which is the closest to what the human eye can see. So we're using black and white cameras. We use them all the time because they're more sensitive than color. But we use color filters in order to make color images. But right now we're just using it in black and white. We have the green filter filtering out all the light except green. So still going to be black and white. So this is the Beehive Cluster in the constellation of Cancer the Crab. This is a good binocular object. It's a very, very simple object to see. You don't need anything real fancy. Binoculars are great, small telescopes. And even the exposures that we're running right now, these 15-second exposures are a little long. So, but we are about 610 light years away from the Earth with the Beehive Cluster. And I know I've got my little box in here. Let me turn this off because basically the entire view is the Beehive Cluster. The Beehive Cluster is an open cluster in the constellation of Cancer the Crab. It's 610 light years from Earth. So the light you're seeing left there 610 years ago. It's just now getting here. A little bit of a drive. And it's 12.5 light years in diameter. So going the speed of light, which is about 6 trillion miles a year, it would take you 12.5 years to cross the cluster. And this was actually first mentioned by a Greek poet, Eratos, in 260 BC, and called it a little mist in some of his poems. But it was later added in 1769 by Charles Messier to his catalog, in the Messier catalog, and this is M44, is the 44th entry into the Messier catalog. So if you've ever gone out and wanted to do some deep sky viewing, the Messier catalog is probably the easiest catalog that you can do for deep sky. This is the 44th entry into the Messier catalog. which was put in by Charles Messier in, once again, 1769 is when he cataloged this. But there has been documentation as far back as 260 BC regarding the Beehive Cluster. Now, if you have a chance and your skies are clear, even with the moon up, this is a really fun object to show people. Very good in small telescopes, binoculars. In a dark sky, you can actually see this haze naked eye. So you can understand why some of these poets call it little mist, because it does look like a little mist floating up in the sky without any additional optics needed. And that is M44, the Beehive Cluster. I'm going to stop us here. We're ready to go on to the next target. If I'm going too fast or there's something you want me to go back to, just let me know. The telescope is very easy to fling across the sky. This next one, though, is getting rather low in the sky. It's in the constellation of Gemini, the twins. And we're not too far away from that when we're in Cancer. So we're going to flip that over. And this one's going to need really short exposures so we don't blow any of the core out real quick. Let's see how this looks. We might have to change filters, but we'll give it a go here. See how it looks. Not too bad, but we can zoom in. So this right here is the Eskimo Nebula. And the Eskimo Nebula is a planetary nebula. We are streaking a little bit. There's a little bit of drift on the telescope. But this is the Eskimo Nebula. The Eskimo Nebula is a planetary nebula. So we have a sun-like star, or a star that's like our sun, that eventually dies. It runs out of its fuel and sheds off its outer layers into space. So you can actually see right here, and if let me stop this, and we're going to switch filters real quick and see how some of this looks. Because right now we're in the visual wavelength, so our eyes can detect all this light. But if we switch some of this out and go a little bit dimmer and go to a very specific type of filter called a narrowband filter, it cuts out a lot of light but highlights the light from this particular nebula. So we're going to switch that filter into place and see how it looks real quick. You'll see it change right before your eyes. Boop. This is an oxygen 3 filter. So now we're looking at double ionized oxygen coming from this nebula. So you can actually see the inner portion, the inner shell. Let's see if I can make this a little bit bigger. We're really zooming in on this particular object here. And if you're wondering what we're looking at, right here in the square is what we're looking at. This is the Eskimo Nebula. We're really zoomed in with this particular nebula. And we have this set up in our oxygen 3 filter that's actually highlighting the double ionized oxygen in the nebula. So when a star like our sun dies, it sheds off its outer layer into space, which you can see the outer shell right here. And it keeps expanding. This is about a light year wide, about 6 trillion miles in diameter, and expanding about 1 million miles a day. And inside the center there is a star, the leftover core, a white dwarf from the original star. Let's see if we switch the filters out real quick. So now we're going to go from oxygen to hydrogen. And hydrogen is going to show us a slightly different look to the nebula here. And we'll see how that changes up things real quick by taking a look at different wavelengths of light in the spectrum. So you can see there that it actually changed. We can get more detail. Right here we can, well, we're getting a little blurry. We might have gotten a breeze that shook the telescope. But we're looking at that in hydrogen right now, or glowing hydrogen in the leftover portions of this nebula. So this is like I said, this is the Eskimo Nebula, constellation Gemini. If you want to impress your friends, it says NGC, or New General Catalog 2392. It's located in the constellation of Gemini at a distance of 4,200 light years away from the Earth. So the light that we're actually seeing left this particular nebula about 4,200 years ago. It's just now getting to us. So it's a long drive for some of this. And this was originally discovered by William Herschel in 1787. Supernova Hunter, this is actually in hydrogen right now. We have a little bit of a breeze. Let me stop this and restart it. Clear out some of the image there. But we are at hydrogen alpha. And if you know anything about filters or imaging, these are very, very narrow filters that we're using tonight. These are actually 3 nanometer bandpass filters. These are the narrowest filters that you can get, which helps cut out a lot of the city light and moonlight, particularly with the hydrogen filter. So that's why we're using this right now. So we are on the Eskimo Nebula. It's a small planetary in Gemini. You can actually look this up with the Hubble pictures. It really looks like an Eskimo. But you can see the inner bubble right here, and then the outer bubble on the outer shell there, which is really, really kind of neat. And that's the Eskimo Nebula. Very cool nebula. It's good in telescopes at about 8-inch or larger, and if you have some serious aperture, like a 16 or bigger with some long focal length, you can really pull out the detail with some high power viewing. If you are viewing it from your backyard, it does take some magnification, and the aid of a UHC or ultra high contrast filter or a oxygen 3 filter is a great addition for your visual experience if you want to give that a go. Photographically, you can shoot it in all different ways, visual or with special filters like we're doing right now. This is narrowband using a hydrogen alpha filter. And just for the fun of it, we're going to flip the sulfur filter into position. We don't use this one too much, but we just want to see the different changes by seeing what sulfur remnants are inside of here. There's probably not going to be a whole lot. Yeah, as you can see right there, the nebula practically disappears. So there is not a lot of sulfur in this nebula. And this is the cool thing with these filters, is you can basically do chemistry with these. So right now we're looking way over on the red part of the spectrum. And as you can see, there's almost nothing there except the core, the very core there. But if we go back and we go to the oxygen filter, which planetary nebulas have quite a bit of double ionized oxygen in them, you'll notice that it just explodes in brightness because this particular wavelength of light, the nebula emits more light in it. So it's pretty cool. As you can see right there, it's much, much brighter with those filters, and understanding your object and what you're observing and the wavelengths will actually help you capture really, really neat images of those particular objects. So again, this is the Eskimo Nebula. It's a planetary nebula in the constellation of Gemini, 4,200 light years away, about 1 light year in diameter, and originally discovered by William Herschel in 1787. So I think that wraps up this particular target and gives us a nice planetary nebula, because right now we are in galaxy season. We're kind of waiting for all the summertime stuff to come up, which shows us a lot of nebulas, and all the winter stuff is basically come to an end. It's in the trees or set already, so we're kind of limited on what we can catch. But we're going to go off to our next target. We try to make sure you get a pretty wide variety of objects to see without too many duplicates. And let's see. Oh, one thing I would like to do before we lose it. Let's see. I'm sure most of the astronomers that are here, maybe if you're interested in astronomy, or if you've joined us the last couple nights over the last few weeks on this channel, we've been taking a look at Comet Atlas. And right now, we were hoping in June that Comet Atlas was going to be almost naked eye visible, but from observations from the Hubble Space Telescope and some other professional telescopes, we've actually found that the comet is disintegrating, which does happen as comets come in towards the sun. They heat up, it gets hotter, and they break up. You can think of a comet as a big dirty snowball. So as it comes towards the sun and that heats up, that material starts to break apart. It becomes more diffuse. So you can actually see it right here in the center here, and it is not nearly as pinpoint as it's been the last couple nights we were observing. It's really starting to fall apart because it's making its way in towards the sun and falling apart. So that is Comet Atlas, or what's left of it for that matter. It's fairly dim right now, so you really do need photographic equipment like what we're using tonight to even catch it, or I guess a big telescope in a very dark location to catch it. But there's not really a whole lot more to grab at the moment. There is another comet that seems to be coming up, Comet Swan. I don't have all the details on it because most of the time it's in the southern hemisphere at this point, but it should be making its way further north, hopefully over the next couple weeks. So we'll keep an eye on that, and maybe coming up on our next couple broadcasts. We do these every other Friday, by the way, and all that information can be found on the focusastro.org website under events. You can see when we're doing all of our Star Stream episodes, but generally every other Friday night, just so we have enough time for the sky to move and rotate and get new objects into the view. So we are currently on Comet Atlas, or what happens to be the leftovers of Comet Atlas, is what we're seeing right now. It is disintegrating, and as it moves towards the sun, so this will probably be, there's probably not going to be much left in 2 weeks, but we'll check back up on it and see how things are looking then. But that is Comet Atlas, or what's left of it at this point. So kind of neat that we could catch that. All right, back to our regular scheduled program. We're going to move over to another object real quick. Get the telescope over there. And get back onto our camera systems and fire this up. So like I said, I try to make sure that we have a wide variety of objects to take a look at. So you get a pretty cool selection of stuff. And obviously tonight the moon is up, so we spent some time on the moon. We did Venus. We got to see the phases of Venus. And we did an open cluster. We got to see a comet, a planetary nebula. And now on our next target, which you can see right here in the center of the field of view, is another cluster. And this is called the globular cluster. And our first target for deep sky tonight was the Beehive Cluster, which is an open cluster of stars. This cluster, which is known as NGC 2419, which is in the constellation of Lynx, is a globular cluster, which is a dense ball of stars, usually hundreds of thousands of stars in these clusters. And this particular one is one of the most remote clusters in the galaxy, about 240,000 light years away from us, about 360 light years in diameter. It's big cluster, but it's so far away that it can be difficult to see. And this one was also discovered by William Herschel in 1788, And like I said, it's one of the most remote globular clusters in the galaxy. And this thing is way out there. Just to give you an idea of how far out there, it takes 3 billion years for this cluster to go around the galaxy once. So way, way out there. And again, this is globular cluster NGC 2419, and also known as the Intergalactic Wanderer. And the cool thing about globular clusters is there's about 150 of them in the Milky Way, and they actually form a halo around the core of the Milky Way. Most of the time, these are visible in the summer months, but this one is one of the few that we can actually catch in the wintertime. So this is NGC 2419, the Intergalactic Wanderer, 240,000 light years away from the Earth. So just a hop, skip, and a jump down the road. And this is a good challenge object. Generally something in a 10-inch, maybe 12-inch or larger telescope. In a dark sky, it would really help. But with a camera, you can start to bring that out more. It's just that the cameras are way more sensitive than the human eye, so it allows us to really dig in and see what's out there. So once again, this is NGC New General Catalog 2419. It's a globular cluster in the constellation of Lynx, also known as the Intergalactic Wanderer, and 240,000 light years away from the Earth. So if you're looking for a fun object that's a bit of a challenge to see, head over to there and check it out. We're going to go ahead and stop our exposures on this target, and we're going to flip over to another one. This is a fun one, and this is the first time we're going to be doing it here because it's now finally season for it. It's clearing the horizon line. It's officially spring, and all the galaxies are up at this point. So this is a fun one, but it's way down in the south portion of the sky. So we have to dive way down there and see what we can get. So we're going to get the telescope down there, and it's on the target now. And flip back over to our cameras and hit expose and see what comes up. Now, this is a favorite if you have an interest in checking out galaxies, and this particular one is called the Sombrero Galaxy. So it's very cool. As you can see right here, Sombrero Galaxy, also known as M104. And this is several million light years away from, about 28 million light years away from the Earth. This is known as an edge-on spiral galaxy. So you can see that glowing core in the middle there, and you have a beautiful dust lane going across the middle of the galaxy. And this is an edge-on spiral galaxy, and this is in the constellation of Corvus, the Crow. It's a little boxy looking thing down towards the bottom, and kind of a very cool, very small. You'll need a lot of focal length or good magnification to actually catch it. So this is something that you can actually try for yourself. It's actually pretty easy in telescopes about 6-inch in aperture. If you can get a little bit bigger than that, you get a little bit more punch. You can definitely make it out from a basic backyard. So it's something that you should give a try. If you're stuck at home like the rest of us, pop the telescope out, give this a shot, and try to catch M104 in the southern part of the sky there. And that is about 28 million light years away from the Earth, 69,000 light years in diameter, in the constellation of Virgo. And this was originally discovered by Pierre Méchain in 1767. Pierre was actually the assistant of Charles Messier. So this is the 104th addition to the Messier catalog. And this is in the constellation of Corvus the Crow. Designation is M104. So go out and give this a shot. You should be able to at least get the little haze. Larger telescopes will give you the more defined dust bands, and in a dark sky, it really shines. You get a lot of really nice detail, especially in a big telescope. So very, very cool thing to see. Now, not too far, actually almost within the same field of view, this is a fun one, and a lot of people don't pay too much attention to this because it's not really a true cluster of stars. Let me get the catalog number here for this correct bundle of numbers, but it's literally just right next door to the the Sombrero Galaxy, or M104, right next door. This is one that I've actually done for outreach quite a bit, and the group I work with a lot, we tend to do this one a lot. It's a fun little cluster of stars, even though none of them have to do anything with each other. This is more known as an asterism, which is actually a collection of stars that just form some kind of fun image. The Big Dipper is actually an asterism. The constellation is Ursa Major. But this is very similar to that. So this one's kind of cool. This is known as Stargate, and many of us are familiar with Stargate. Let me readjust our little square here. So this is the Stargate star cluster, which is really close to the M104 galaxy. And Stargate is a collection of 6 stars. You have a triangle of stars, and inside you have an inverted triangle of stars. Doesn't take much to see these. You can see this in like a 6-inch telescope. It's really fun to do at outreach events, just because it's just a fun little thing that people can relate to. But this particular cluster, the stars actually have nothing to do with each other. They're all at different positions, ranging from 285 light years away to 486 light years. But it still forms this cool little triangle, and it's a fun one to go share out there and see visually in a telescope. So that is a fun little asterism. This is the Stargate star cluster, and something you can go see. Pamela, yeah, you can use, you need a very specific hydrogen alpha filter for doing astrophotography. Obviously, for observing the sun, we have special solar filters for the sun that highlight or allow the throughput of a throughput of light and hydrogen alpha light of the sun. But for astrophotography, we have similar filters. They're not quite as complex, but you can get, here's one right here. This is a hydrogen alpha filter for astrophotography. Now this is a little broader filter than what we're using in the wheel tonight. This is an astronomic 6 nanometer hydrogen alpha filter. Really nice filter, actually. If you're just getting started and you want to try it, get yourself a black and white camera and one of these, and you'll be amazed at what you can get in details, like the Horsehead Nebula and all that with a basic camera. This is the trick, is a H-alpha filter. Now, you're going to see different band passes. Like you'll see it says nanometer and the number next to it. Sometimes you can get them 12 nanometer, 7, 8, 5, 6, like here, 3. And the narrower that is, the more onto the band of light you are, and it cuts out everything else, giving you more contrast. If you're looking to shoot in town, you want to shoot with a full moon up, I'd probably recommend at least a 7 nanometer filter. Like I said, the Astronomic 6 nanometer works really, really well, and they make them in all different sizes. This is the 1.25 inch, but they make them in 2 inch and all the fancy large format sizes. And then if you really want to go all out, you can go all the way up to the 3 nanometer filters, which give you the most contrast, which is what we have in this telescope that we're using. They're all 3 nanometer, but they can be fairly expensive filters because they're ultra precise. So yes, you can use hydrogen alpha filters for astrophotography. Check them out, or you can always email me at focusastronomy@gmail.com if you have any tech questions. I'll be happy to help you out with that. So that is the hydrogen alpha filter. And this object, if you're just joining us, this is Stargate. This is an asterism in the constellation of Corvus. It's a triangle of stars inside a triangle of stars, and it is just a fun little object to check out. Not too far from M104, which is the Sombrero Galaxy. All right. So we've got a couple more objects on the list, and we might add some. We've got about, we're not on a time deadline at all, but probably about another 15, 20 minutes left, and then we'll wrap this evening up. If there's anything you want to see, don't hesitate to ask. There is one object I'd like to try and get. It's really low. We might have to wait about 2 weeks for our next one to get it, but we're gonna give it a shot and see if we can even see it right now, because it's in a really bad part of the sky and it doesn't get very high from our location, but we just happen to have a really good southern horizon here, and I know we can get it, but I think we might have to wait till next one in 2 weeks to see this, but we're gonna give it a shot real quick. Yeah, that's not going to happen. That's way too low at the moment. Maybe we'll try at the end, because this is a tree right here. So it's almost out of the tree. So maybe we'll come back to this in just a second and go on to it. So maybe towards the end there. This next one, though, is a favorite of mine, both visually and photographically. It's really just quite a stunning galaxy to see. It's amazing in a large telescope in dark skies. This one would be a bit of a challenge in town visually, but you're more than welcome to give it a shot. I always recommend giving it a shot. If not, it doesn't work out, no big deal, whatever. So this is the Needle Galaxy in the constellation of Coma Berenices. This will be one that we'll be going back to over the next couple because it's such a cool galaxy, but it's known as the Needle Galaxy. And let's zoom out here. So we're going to give the camera a little bit of time to get some good detail on it. We are fighting a pretty bright moon tonight, so our backgrounds are not as dark as some of our other webcasts have been, because we're dealing with a lot more moonlight in the night sky. But this is the Needle Galaxy, NGC 4565, in the constellation of Coma Berenices. This is 39 million light years away from the Earth, and this galaxy is huge, about 190,000 light years in diameter. This is a big galaxy. I think it's got something like 200 globular clusters in it. It's huge. And in a telescope, in a dark sky, it's really cool. It looks like a big old UFO. And there's tons of other little galaxies in here because we're near the Virgo cluster. There's a little one right down here as well. So the Needle Galaxy was originally discovered in 1785 by William Herschel. Herschel did a lot of discovery on these really faint little deep sky objects, and this is just one of them. So if you're just joining us, this is NGC 4565, the Needle Galaxy in the constellation of Coma Berenices. It's an edge-on spiral, so it does have spiral arms, but because of our positioning, we're looking at it like looking at the edge of a CD, if anybody even pays attention to that anymore. But looking on edge, so we're looking right down the edge of it, and and that is the Needle Galaxy, NGC 4565, in the constellation of Coma Berenices. Very, very cool object to catch and photograph. If you get out to some dark skies with your telescope, like an 8-inch telescope, give this one a shot. If you've got a bigger telescope than 8-inch, this is really cool. Or if you've got a friend who's got a really big telescope and you're in dark skies, have them throw it on this galaxy, because it's really impressive when everything's working. The detail that you can get inside this dust band is very, very cool. So something to definitely check out. This is NGC 4565. The filter we're using right now, Alex, is actually a green chrome. It's made by a company called Chroma. All the filters in this telescope are Chroma filters, and this is just the standard green filter. It's not really a light pollution filter at all. A light pollution filter would probably be more helpful, making the backgrounds darker, but yeah, this is just a green, standard green broadband filter for doing RGB imaging. So this is the green filter, and the reason we use green is the human eye picks up green the most, so this would be very close or similar to what the human eye would see through a telescope. So that's why I use the green filter the most. We have blue and red in there, but the human eye isn't as sensitive, and nor is the camera, so we lose a lot of detail. So this is the green filter from Chroma. All right, so this is NGC 4565, the Needle Galaxy in Coma Berenices. And while we're up here, we're going to check out another really cool galaxy. We're going to try to see if we can see a certain detail on this galaxy. And it's not too far from where we're at, but nope, we're already there. So let's see what we can get out of this. This one's really neat. As long as we can pull out what we want to see. We might have to wait 2 weeks when the moon is down. So our next showing of this is going to be May 15th, weather permitting, of course, Friday, May 15th at 8:30. It's getting to be summertime, so we need to wait for things to get a little darker. So we're pushing it back an hour and a half. So we're in the middle of the Virgo cluster now, in the constellation of Virgo. And this is M87, and M87 is also known as Virgo A. And Virgo A is a huge elliptical galaxy. It's about 113,000 light years in diameter, about 55 million light years away from the Earth. And I don't know if we're going to be able to, and the longer we expose, there's a galaxy, there's a bunch of galaxies in this area. So it's going to be kind of neat. I don't know if we're going to be able to see what I want to see tonight, though. We're going to flip over to the blue filter, because the detail that we want to see is actually highlighted more in the blue wavelengths of light. So we're going to switch over to that real quick and see what we can see. So let's see what comes up there. And nope. So we're going to have to wait on this one till next week, or the next one on May 15th to get it. But M87 has a massive black hole inside of it. And while we cannot see black holes visually, at least with this equipment, I do not have the budget for something like that. We can see it, the jet that comes out from that galaxy. And that's something generally that we've been able to capture with this telescope. But the skies need to be a little bit darker with less moonlight. And that's why it's kind of gray in the background here. We just don't have that dark enough sky. So if we wait 2 weeks for May 15th, if you join us for that one, we're going to be digging into galaxies, really seriously digging into galaxies. we're going to give that a go. So definitely join in a couple weeks on May 15th, weather permitting, and we're going to really dive off the deep end as far as reach, and really see what we can see floating out there. So this is M87, an irregular galaxy in the constellation of Virgo, also known as Virgo A, 55 million light years away, 113,000 light years in diameter. So that's kind of it for my list for this evening, but we can pop around on a couple more objects before we call it a night. We do have some cool galaxies that are kind of nice and high right now. Again, we are in galaxy season, so we're not looking along the Milky Way. We're actually looking out into intergalactic space at this point. So let's flip our filters back and get this started. This is actually probably my favorite galaxy to look at. It's really well known as well. And many people have seen it. You can see it in telescopes as small as 6-inch or even smaller. I've seen it in 4-inch, but if you've got a big telescope, it's really impressive. I see you guys are talking about a 20-inch in the chat. This would really just knock it out in a dark sky. But this is the Whirlpool Galaxy. This is actually in the constellation Canis Venactices, not far off from the handle of the Big Dipper. And this is about 30 million light years or so away. And it has a companion that it's actually already interacted with, and they've actually found that the companion is actually behind the galaxy, the main Whirlpool Galaxy, which can be seen right there in the center. So that's pretty neat. This is actually M51 or Messier 51 in the constellation of Canis Venactices. So something pretty cool to see. This is an amazing galaxy in a dark sky and a big telescope. So this is the Whirlpool Galaxy. These are interacting galaxies. You have one galaxy here, and you have the arm bridging off to the irregular galaxy right here. These have already interacted, and they're separating. But the little companion down there is actually behind it slightly, so they kind of sideswiped each other at that point. So something pretty cool to see there. So very cool stuff. Very neat things to see at that point. Now that's pretty much, let's see if we can get a couple things here real quick as my computer starts to give me of course its usual stuff. Bear with me just a second. Let's see if we can get those galaxies real quick, Chris, and we'll see if we can do the antennas. Let's see what's going on. All right. Bear with me just a second. My system disconnected from me real quick. We're going to try to reboot into here. This happens sometimes when you're running these systems. You've got so much stuff going on that it gets a little difficult balancing some of the hardware altogether here. So we're going to flip back onto our remote system. Because the way this works is we're actually remoting into the telescope outside, and we're inside. That way we're not getting eaten alive by bugs and all that fun stuff. So let me try to get back onto my remote system here. And we'll get back up and running here in just a second. We'll do a couple more galaxies and then we'll wrap up the evening If there's anything you want to see, just let me know. All right, there we go. We're back online. So, what are we doing? The antenna galaxies. That is NGC 4038. These are way down in the south, so we're gonna slew down here real quick. See if we can get a hold of some of this stuff. All right. Give me just a second. My computer is not happy with something. So, might have to cut this one short tonight. I'm not sure why my computer is giving me the issues that it is. But it is. So, hold on just a second, guys. Let me reset something really quick, and we'll get back to you in just a second. All right, well, I think that's probably going to have to be it for tonight. My computer is giving me some fits right now. So let me go ahead and wrap up this evening and say thanks for all of you guys tuning in. And apologies for some of the technical issues on my end there. But the computer is giving me kind of a mutiny at the moment. If you liked watching this, you can always subscribe to the Focus Astronomy YouTube channel, and you can subscribe to that and see when we're going to be doing future webcasts. But thank you all for joining in this evening, and appreciate you watching. And join us in 2 weeks on May 15th. Hopefully my computer won't be calling it a night on me. And we'll be doing all the galaxies, and we'll have no moon up that evening, so it'll be nice and dark, and we will see what we can get that night. So once again, thank you for joining me on another episode of Starstream, where you get to travel light years without ever leaving home. Thank you very much, and have a great night. Thanks, guys.